matrix norm. This one from R m by n goes to R is called matrix norm if it satisfies the following condition. So first we go into the definition and then we look at the properties, which is actually the whole main aim. First property, like any other norm, it is, what can we say about norm of a matrix? Must be greater than 0. Yes, greater or equal than 0 for all A belonging to R m by n, and we understand that norm of A is equal to 0 if and only if A is 0. The second condition is the norm of alpha A is equal to absolute of alpha multiplied by A for all A belonging to R m by n and alpha belonging to R. And the third one, the norm of A plus B is less than equal to norm of A plus norm of B for A and B belonging to R m by n. And what is the name of this? It's called? Sorry?
Commutative. Triangle.
Triangle inequalities. Triangle inequality. Now, this is a different definition. Now we want to talk about very famous norms and a few of the properties. These norms, you use them in computer science quite a lot. Some of them, they use them actually if you want to develop, to approximate some function. The one that I will talk right now is actually used in order to estimate a calculation of the singularity composition. So the first one is Frobenius norm or F norm. Frobenius norm or F norm, or sometimes they call it matrix Euclidean norm, is defined as the summation of each element. The square, we add all of them and we get and we square root and we get the result. This is also equal to that we usually use R. R is, what is R?
Rank.
Rank of A. So in other words, I am adding similar values. I have a question. Can I write it like this?
Yes.
What is the difference between these two? And we understand that we are not saying that A is a full rank. In other words, an A, R might not be the minimum of M and N, but we know that R is less than equal to minimum of M and N. What is the difference result-wise? There is no difference. What is the definition of rank?
Minimum of work.
What is the definition? We have, I think, 4 definitions of rank. What is the definition of rank with respect to singular value? It's number of non-zero singular values that we have. So if I write it like this, what happens? I'm adding with R, and afterwards I'm adding series of zeros. If R is equal to minimum of M and N, then it's absolutely the same. That's why that usually in the book you see this notation, which is clear. It tells us if 4 of them, the rest of them are zeros, there is no point to add it. This is also equal to trace of A transpose A over 1 over 2, which is the trace of A transpose to power 1 over 2. What was the trace? Do you remember what was the definition of the trace? Summation of the elements of main diagram. So this is the Frobenius or matrix Euclidean norm, F norm, right? The matrix P norm is defined as, now one thing, guys, in the exam, if I give you a numerical number and I tell you that, for example, calculate AF, we know that MATLAB is open, so you can use MATLAB to confirm your result, but you have to calculate it, right? You have to calculate it, which means basically you have to score and add the numbers. So just writing the final answer is not acceptable. So the P norm is defined as similar to vector notation wise. This is the maximum of the norm of A, norm P of X is not 0. And if you pick such a x that the norm of x, the p norm of x is 1, it will be the maximum of ax. So, like the vector norm, when we talk about the p norm, we are talking about now famous computable P norms. And the first one is when p is equal to 1, norm 1. Which is known as the maximum of column norm. Maximum of column sum norm. And we represent it as a 1. It is the maximum over the columns. J's are the columns, column 1, column 2, column 3. What we do, we add all the columns and we pick the maximum. What is the maximum value? And if A is n by n, you understand this stuff from 1 to n. The next one is maximum of row sum norm, which is A infinity. So it's the maximum over the row of summation for J's. In other words, I will add all the rows and I will tell you that which one is the maximum. And first one is the spectral norm. Which is the maximum ion value of A transpose A. We have not talked about the ion value yet, but I remember I told you what is the second norm, norm 2 of a matrix. It is? No, it's one value, but it's a very famous value. It is? We are talking about ion values. There was one thing which we said there are ion values S squared. Should be?
Variance.
What is it? What is this? What is this?
Variance.
Variance. What is this? This is singular value. So which one? First one. So this is the norm 2 will give me the first singular value, which is the biggest singular value. And the biggest singular value is squared is the maximum ion value. You know that. Now, let's do an example. For find find these values? No MATLAB.
Okay.
Use your fingers because it's simple addition. What is A1? Maximum of column sum. Right? Let's add the columns. Look, this is my A. What is the addition of this one? 2. What is the addition of this one? 1. What is the maximum value?
2.
What is the addition of this? 3. What is the addition of this one? 0. So what is the maximum value? Because A infinity is the maximum of row sum. What about A? A square root of 1 squared plus 2 squared plus 1 squared plus minus 1 squared. So 1, 2, 3, 7. We need math.
Multiplying the A transpose and A,
What?
the trace.
Yeah, I mean, which one is easier? Find the transpose of this one, multiplying or just 4 numbers square added? I mean, this is true. You can find the what Algebra says is this. I want to find the trace of A transpose and A. Do it. And of course, you put it under the square root. Now, while Algebra is doing this, I have a question. What is the norm 2 of A plus? Second norm, give me the biggest singular value. Question is, what is the biggest singular value of A plus? Isn't it that it will be, we remember that if A has sigma 1, A inverse had 1 over sigma 1, right? And then this one was sigma 2, sigma 3, and so on, it will be 1 over sigma 2 and the rest, right? Now, if sigma 1 is the biggest, 1 over sigma 1 is the smallest. So, this one is 1 over a smallest sigma. Don't write it. Because 1 over a smallest sigma is the biggest. Right? But what is the smallest sigma? Which sigma is the smallest sigma? The last sigma, isn't it? But what is the last sigma? If the rank is R, it's sigma R. Right? If R is N, it's sigma N. If the R is M, it's sigma M. If the R is just a value less than any of those ones, it's that one. The next type is the scatter p-norm. S and P, and this is sigma 1 to power P plus up to sigma R to power P 1 over P. So can define a mixed norm. And mixed norm is defined as A of P and Q. What was the definition of AP? It was the maximum of norm of xp is not zero, norm of ax, p norm of ax over norm of x. But here we define it as maximum of norm of x q is not zero, norm of ax p over norm of x q. Norm is considered to be consistent if norm of AB is less than equal to norm of A multiplied by norm of B if multiplication is possible. In other words, if I can multiply A by B, the sizes are matched in a way that we can multiply them, then we consider it, we define it to be consistent. And norm is mutually consistent if norm of A by B, norm alpha of A and B is less than equal to norm beta of A multiplied by norm gamma of B, if the multiplication is valid, norm alpha, beta, and gamma is mutually consistent. So you understand that we are talking about three norms. These three norms are mutually consistent if we can write that. Prevalence norm and P norm are consistent, but mixed norm is not consistent. Now we can show you in a numerical example. Like a norm of 1 and infinity is actually maximum of x is not 0. Which gives us if I have this norm, this mixed norm of 1 and infinity, it's actually defined to be the maximum of the maximum element that I have, absolute value, I mean unsigned value. So knowing this, in this example, A is equal to B is equal to this, then we understand that norm of AB of 1 and infinity, norm of A 1 and infinity, norm of B 1 and infinity. You tell me, what is the norm of 1 and infinity of A multiplied by B? Look, the definition tells me, look at here for a second, the definition of norm of 1 and infinity tells me I have to look at my matrix, ignore the sign, the biggest value is my result. So A multiplied by B, what is the biggest number? All the numbers are 2. For A, I look at the A, what is the biggest number? 1. For B, what is the biggest number? 1. You tell me if this is valid. Abdullah, is it true?
No.
Is 2 less than or equal than 1 multiplied by 1?
No.
No. So we say that it is not consistent. So as we said, the mixed norm is not consistent. A few nice norms. Norm of I, norm P of I is equal to 1, where same for F norm, it is a square root of n. Please read page 61 for useful inequalities. There are some list of inequalities which is useful in the sense that maybe we cannot calculate the value of the norm, but we can figure out, okay, the norm is between this value and another value. And that can help us in order to estimate. And finally, for this chapter, we have this important theorem which says that the norm, the F norm, and second norm are unitary invariant, which means for any A of n by n, and for any orthogonal, let me change the marker, for any orthogonal Q belonging to R n by m, and Z belongs to R n by n, we have Q A Z of alpha is equal to norm A of alpha, where alpha is either 2 or F. So it means that if I am multiplying A by 2 orthogonal matrices, the norm is not changing. The second norm and the F norm are not changing. Now, norm will be very useful in least square problem, which we have is our next chapter we should talk about it. Least square problem is very useful because it helps us in order to find out what do we want to do when we want to solve an equation. And solving an equation can be actually any problem, that solving something that you have in image processing, in matching, or in pattern recognition in matching, because you try to minimize something. So how we can minimize, and we will find out why there are multi-results, not only one uniform, one unique answer. We will learn in the next session, which is about this least square problem. Least square problem is very useful in many computer algorithm development. MATLAB is used a lot in order to find the pseudo-inverse. And we will see that how this square problem actually is used in order to approximate our pseudo-inverse, which is like A+. But because I have to be somewhere at 3, we stop here and we continue on Thursday. Before that, we can stop the video, but I can